Alright, so let's look at the distributed file system. So the distributed file system, it is file system, and the difference from the regular file system is that it is spread over multiple machines on the network. So it is another difference from a regular file system is that this system is much larger than the regular file system. So we can have tens of thousands of nodes and millions of files and large data sizes. It's saying here 10 petabytes. So whatever the size of the data is, this system is scalable because it breaks it into multiple pieces that can be stored over these commodity computers. So assumes commodity hardware files are replicated to handle the potential failures, and the system, when it detects a failure, it relaunches the work that the failed node was supposed to do. Primarily, it was designed for batch processing, like we mentioned earlier, for these large text files, searching through them, such as Facebook, or searching through people's posts, messages, or the Google searching through pages, and so on. So that's why it is pretty much working in a batch fashion. So it is efficient for unstructured data like that. The locations of the data can be moved, and the idea is to move them closer to where the computation will be happening. In this way, we make it more efficient. The way it is designed is, we have seen that we have this many data nodes connected together in a hierarchical fashion, and we mentioned there is this NameNode that manages the data nodes. There has to be a central place that knows where are all the data nodes and where are all the parts of the data and how to find them. So there is a single namespace for the entire cluster that has all of this information. Clients can connect to this namespace or NameNode and request information from it to find out, to determine the location of the files. The way the system is optimized is that we have write once, read many times model, because reading is faster than writing, and so clients can also only append to the existing files instead of overwriting them or deleting them. So we will take the large data file and split it into blocks. That is what each operating system is doing. As we mentioned, the operating system on our laptops, the block is much smaller. Typically, the block on this distributed system is 64 megabytes. The reason for that is because we have large data files, and they can fill up these blocks. If you have this size on our laptop, and we just create a text file that is 1 megabyte or less, and it's stored in this block, then the rest of the block can be wasted, and wasting memory like that. So each block, this size can be changed. It is configurable. It can be changed from 1 megabyte to more than the 64 megabytes. It depends on the particular system and the application that we need it for. Each block is replicated several times in case one fails. The copies will be used to recover. Clients can connect to this NameNode and to make requests. For example, finding the locations of all the blocks and access the data, and then they can go to the data nodes and access the data from there. So the data nodes will store the data, and the name node will manage into which data node what data is stored. And so the clients will request this information from the name node, and then go to the data nodes to obtain the data from them. So this is how the architecture looks like. There is this name node. So Hadoop distributed file system architecture, there is the name node, and these are the data nodes. The data nodes have parts of the files in them, and then there is this client that it can contact the name node to find out the pieces of the files, which is also called metadata, because to find where the files pieces are. And metadata, because it is description, metadata is description about the data. In this description is what is the name of the file, where is it located, and where are all of its copies, replicas. So client can obtain this information from the name node, and once it has that, it can go to the data nodes and obtain this data, or write into the data, or do whatever it needs to do with it. So the main thing is that we have multiple data nodes where the data is stored, and we have the name node that knows all the locations. So what are the functions of the name node? It manages the file system namespace. So for this entire cluster, the name node knows, maps a file to the set of blocks that are part of this file, because the file could be bigger than one block. So it's going to be broken into multiple blocks. And then it maps the block to a data node where it will be stored. Also, it manages the configuration of any configurations of the cluster, and how many times the blocks will be replicated and where the copies will be placed. So this is a very important function. What if so this name node knows where all the files are, and what if it fails? What if the name node fails? Does that mean the entire cluster will be dead? So we do have to create a backup of it, right, for just in case. So we have two of them. There is a secondary name node that will take over if this one fails, and it serves as a backup, and it also does some other functions. So so what is in the metadata? We said metadata is description about the data, but the name node will keep this whole thing in its main memory for fast processing. What can be in the metadata? List of files, list of blocks for each file, list of data nodes, where each block is, and any other information about the files. The owner of the file, the size of the file, the last modified date, and so on. The data node is also called a block server, so it's going to store all the data files and serve the clients. So if the clients need to do anything processing with this data, the data nodes will serve them. And it also, they create a report and periodically for everything that they are storing, and sending it to the name node. They can also forward data to other specific data nodes. We mentioned we have keeping 3 replicas or 3 copies of each block. One is on a local node, second is on a remote rack, and a third, it could be, third could be on the same remote rack or on a different remote rack. And we can also place more copies if we want to. In that case, we place them randomly. Another thing is that these data nodes can fail. How do we know if the data node failed?
Smoke coming from the rack.
There could be smoke, somebody set it on fire, or it was burned by a nuclear war or something else. But how does the NameNode know if the NameNode is far away from? So they are periodically sending some pulse or heartbeat to the NameNode about every 3 seconds to tell it that they're alive. And if the NameNode stop receiving these heartbeats, they know that the data node is dead, and they need to assign its functions to another data node.